This is a BC Eagle Finance video, a supplement to Brigham and Houston Chapter 5, Time Value of Money. The time value of money is a very important topic in finance and any business course because all financial transactions are driven by the concepts that you have in this particular chapter. If there was something that your parents and any employer would like you to know in getting out of college, it would be this concept, how to handle the time value of money. So, let's get to it. There are four main topics for the time value of money. The future value or compound value, what money today would be worth in the future if it could be invested at a certain interest rate. Present value, what amount would you pay today to receive a certain amount so many years from today, and then applying those two topics to annuities. If you put a regular amount away at regular intervals, how much would you have at a date in the future? That's like saving for education or retirement. And the present value, if you were to receive fixed amounts in the future at regular intervals, how much would you pay today to get those regular payments in the future? That's the present value of an annuity. So what this video will do is to take a look at each four of those elements one by one and also introduce you to the time value of money calculators. By the way, this will be two of the three times that you folks will see this in your college careers. You have been introduced to it in Principles of Economics, you have seen it in Principles of Accounting, and I guess you're seeing it already for the third time in Principles of Finance. So all the time value of money lessons that you've had before should be consistent with what we're going to do now. If you notice any differences, please ask about them because these concepts should be consistent. Okay, first, let's look at the future value of a sum. This is a spreadsheet approach to the future value of a sum, which says that if you would invest an amount of money today, how much would it grow to in the future? So let's assume that we have a 10% interest rate. If you put $1,000 away today, you would get your original $1,000 back, plus you would get $100 of interest, or 10% of the $1,000, on top of the $1,000, so at the end of the first year you would have $1,100. The mathematical formula for that would be the amount that you put away today, $1,000, times 1 plus the interest rate, in this case 1 plus 10% or 110%, and you would raise that quantity to the number of periods power. So 1.1 to the first power would be itself times 1,000 would give you $1,100. If you were to put away $1,000 for 2 years, you would get $1,100 at the end of the first year, and then you would get another 10% on that $1,100, or another $110 to accumulate $1,210 at the end of 2 years. So the formula for that would state, take the amount that you put away today, $1,000, times 1 plus the interest rate, 1 plus 10%, raised to the 2-year power. That's like taking 1,000 times 1 plus the interest rate times 1 plus the interest rate to get 112. And what I'll suggest that you do is to get your calculators, stop the video as necessary, and practice these amounts. Going one step further, if you put away $1,000 for 3 years, you would accumulate $1,100 at the end of the first year, $1,210 at the end of the second year, and then 10% more would allow you to accumulate $1,331 at the end of the third year. That would be like taking your initial deposit, $1,000, times 1 plus the interest rate, 10%, raised to the third power, or 1,000 times 1.1 times 1.1 times 1.1. That accumulates to $1,331. So there you have it, time value of money. This is known as compound interest or interest on your interest. A couple of other things I'd like to do with this particular slide. Number one is to introduce you to the calculator apps that are available for your cell phones. And if you would go to these websites, if you have an Android phone, you would go to Google Play. And if you would have an Apple phone, you would go to the iTunes store. The Android has a free app at this Google Play. Apple is a different animal, and they do charge. I'll recommend the $5.99 app because it works just about as good as the high-price $14.99 app, and I really don't notice a difference. There is a free one out there from Tom's Guide, no relation here, but I cannot speak to it. I haven't used it, but I have heard that it does a pretty good job. I'll let you take the risk if you want to download that one. Another thing that I'd like to do is to show you how to use your calculators. So I'll suggest right now that you stop the video and then download the app that you want to use for your phone, and then turn the video back on to the third element here, which is how to use the calculators using the time value of money keys. Now that you have your calculators, let's take a look at how you would calculate each of these three items. So the calculator will have 5 keys on the screen. N represents the number of periods. I/Y represents the interest rate per year or per period. PV is present value. PMT is payment, that's the annuity. And FV is the future value. CPT is the button that you would push to compute a particular value. So let's say that we want to calculate the future value of a sum for 1 year. That's this $1,100 that you see that I'm circling. So you'd enter 1 and then push the N key. 10 in percent is implied. Don't put in 0.10, just put in the number 10, and your calculators will assume that that whole number has a percentage sign after it. And then push the I/Y key. Enter in a negative 1,000 for the present value, because in order to buy this investment you have to pay money, so you are reducing your checking account. So negative 1,000 for the present value. There is no regular payment or annuity associated with this future value. Enter 0 and then push the compute FV key, and on your screen you should see the 1,100. Doing the same thing for the second year to compute the 1,210, enter in 2, push the N button. 10% implied, push the I/Y button. Enter a negative $1,000 for the amount that you would deposit in the investment account, push PV. Enter 0 because there is no regular payment, push the payment button, and then push compute FV, and you should see $1,210. Let's try this one more time for the 3-year future value. N would be 3. Interest per year would be 10%. $1,000 is the amount of your deposit. Enter that as a negative. There are no annuity payments. Enter 0 and then push compute future value to get $1,331. Okay, that is the future value of a sum. Next, let's look at the present value of a sum. The present value of a sum is the reverse of a future value. So here is the setup. If you have an amount in the future, how much would you pay for it today if you wanted to earn 10%. The short story is that the present value of a sum is the reciprocal of the future value of the sum. So you would have the amount in the future and now divide by 1 plus the interest rate taken to the number of periods power. Try this in your calculators. Enter 1,000 and divide it by 1.1 and you should get $909. That means if you invest $909 today at 10%, you will accumulate $1,000 in the future. And to test that out, what you could do is to multiply 90909 times 1.1 and you should get 1,000. For the $1,000 that you would receive in 2 years, you would divide that value by 1 plus the interest rate taken to the second power, and that produces $826.45. You would pay $826.45 today. When it's invested at 10%, it will accumulate to $1,000 in 2 years. And finally, for the $1,000 that you would receive in 3 years, divide it by 1.1 taken to the third power, and that would result in you paying $751.31 today. $751.31 invested today at 10% would accumulate to $1,000 in 3 years. Working your calculators to do the present value of a payment that you receive in 1 year, you would enter 1,000 and push your FV key. There is no annuity payment. Enter 0 and the payment key. Your interest rate per year, 10% is implied. Push the I/Y key, and then you are going 1 year in the future. Push 1 and the N key, and now push compute PV, and you should see a negative 90909, which the negative amount means you would pay that amount to receive $1,000 in the future. Now try the other 2 years on your own, and if you have any questions, please let us know. Third item is a future value of an annuity. The distinction between a future value of an annuity and a future value of a sum is that the annuity represents a fixed amount received at regular intervals. An ordinary annuity assumes that the first payment will come 1 period from the present. So the first interest payment, or the first payment that you receive, comes 1 year from today, the second payment 2 years from today, and the third payment comes exactly on the anniversary of the 3rd year and will earn no interest. So the first payment will earn 2 periods of interest. So you'll take the $1,000 times 1.1 squared to get $1,210. And the second interest payment will accumulate interest for 1 year. So 1,000 times 1.1 gives you $1,100. And the final $1,000, because it's received on the anniversary date, does not accumulate any interest. So if you add the future value of the first item, the second item, and the third item, the future value of the 3 $1,000 payments would be $3,310. Working this same thing with your calculators, you would enter 3 for the number of periods, 10% implied for the interest rate per year, 0 for the present value because there's no cash flow at the immediate time, and the payment that you would make would be $1,000. That's the $1,000 annuity. And then push compute future value, and you should see $3,310 on your screens. And finally, let's review the present value of an ordinary annuity. Wow, this screen looks a little bit busy because there are a lot of concepts in here. Specifically, the present value of an ordinary annuity is the basic idea behind bonds. And so what you have in this screen is a little bit of a review of what you folks had in Principles of Accounting. Here are the interest or the journal entries that you would have made in Principles of Accounting for interest and bond discount amortization. I'll let you look at this right-hand side at your leisure, but we want to go over the present value concept principally here in finance. So here's the setup. With a bond, you receive two things. You receive the interest annuity, and you receive the principal when the bond term is up. So in this case, we have a bond principal of $10,000. The bond is paying a coupon interest rate of 10%, or 10% of 10,000 would yield an interest annuity of $1,000 each year. And if we would discount each of these four interest payments, we would have the most that an investor would pay for this bond if the investor wanted to yield 11%. So let's take a look at how this would work. 1,000 divided by 1 plus the yield rate, which is 11%. So 1,000 divided by 1.11 taken to the first power yields $900.90. The second $1,000 would be divided by 1 point the yield rate, 1.11 squared. That results in $811.62. And the third $1,000 payment would be divided by 1 plus the yield rate, 1.11 cubed. That results in $731.19. Add these three present values together and it accumulates to $2,443.71 as the present value of the interest on the bond. So if you had a choice between receiving three $1,000 interest payments at the end of the next 3 years or a lump sum today, you would pick $2,443.71 as the lump sum you would receive today. And then finally, we would need to discount the principal of the bond. 10,000 divided by 1.11 cubed would result in $7,311.91 as the present value of this future $10,000 payment. Adding the principal's present value to the present value of the interest gives you $9,755.63 as the price that you would pay for this bond if you wanted it to yield 11%. Working this with your calculator, because the bond had 3 payments, 3 would be the number of periods. The bond's yield rate, what investors want to earn, would be the discount rate that would be used, 11% assumed, interest per year. The interest coupon rate would be the 10% coupon times 10,000, or $1,000 of interest. And the future value is the face amount of the bond, 10,000. Touch the compute present value and you get 9,755.63 as the most amount or the largest amount an investor would pay for this particular bond. Well, there you have it, the 4 time value of money tables. A future value of a single sum, a present value of a single sum, future value of annuities, and present value of annuities. Practice each of these, Make sure that you can use your calculators as well as the formulas, and I think you'll do well on the AST questions as well as some supplemental problems that will be coming. Thank you for listening. Do well.